Good morning, I'm Jim Armstrong, and what we are going to do today is to do a screen and then a clean of the pulp fiber. So in our previous video we went through and we mixed up liquor, we measured out our weight of our chips, we measured moisture content in the chips, then we loaded the chips into the digester, we metered liquor into the digester, the chips were cooked over about a 3.5 hour period, and then finally we blew the chips out of the digester into the blow tank. Then we transferred it over to stock tank number 3. And then the second step was to actually take the stock in stock tank number 3 and run it through a brown stock washer, and we washed all of the liquor out of the pulp stock itself. And the very last thing we did was we actually measured the consistency of it and calculated the yield. That was how much fiber had actually been produced. So now the next stage is to clean out the shies, the little chunks that are sitting left in the pulp fiber itself, little bits that didn't get cooked. And an example of that, I remember way back when I was in grade school, they used to give us something called foolscap, which we would, in this day and age, probably call it legal paper, legal size paper. And it was kind of neat, because you look at this piece of paper and there would be little tiny specks of wood still in the paper, cheap paper. And that paper had been made with unscreened stock. So we're going to take it to the screening stage where we're going to filter out all of that paper, all of that fiber, and the solids are going to stay behind. And Charles, I'm just going to move over to the screen itself. So if you follow me over here. So I've got a couple of spare screens in my hand, and you can see that this one's got smaller holes in it, this one's got larger holes in it, and the one that is actually installed over here in the centrifugal screen has got even larger holes still. And so the screen is sitting in here, if I get my laser out. The screen is inside. And there's a rotary blade that's going to move around there, 4-point blade. And I'm going to, just for a few seconds, turn this thing on. It's going to make a racket, but you should be able to see the blade moving. Okay, so again, this is the screen. There's medium-sized holes in here. And then Charles, if you can kind of get a picture right about where my finger is pointing in there, getting close on it, you can see that this one's got even larger holes. And if you come back a little bit, Charles, the screen is actually sitting jammed in there like that. Okay? What will happen is that when this thing is spinning, it's going to push the accepts, the fiber, through the actual holes, and the fiber will go down through here into that stock tank. Any big chunks are going to be stuck behind the screen, and they will come out through this line here. We're going to apply some flushing water on, and the flushing water will go in there and flush, hopefully, those chunks out. Sometimes this is kind of small in diameter, and so sometimes it plugs up on us. But you'll see this when it's actually running. And just before we shut this off, I'm going to turn on the screen right now. It's noisy, but you will be able to see the blade actually moving. There, it's spinning. You can imagine this thing spinning around and just shoving stuff out of the holes, but the big chunks are stuck behind, and we'll wash them out. Okay, so we're back now at the operating screen, and I don't know how well my mouse is going to show up, but we're taking pulp stock out of stock tank number 2. This is the washed stock. We're going to pump it through that stock pump number 1, and it goes up and it comes into the screen itself. It actually gets pushed in from behind. Okay, we're going to take this cover off of the screen so that you can actually see what's going on. We've taken all the other screws out. I'm just going to take this last one off. hopefully not drop it. Okay, so I've loosened off the bottom rubber sleeve that's going down there. I'm going to take this guy off. In industry, it would not be made of plexiglass. This is for demonstration purposes, and they'd be significantly larger than this. This is the screen, and I'm going to remove the screen now. So now you can see the size of the holes in there. Now, what I want you to see is that the stock that was coming in comes down through this line, and right about in here it goes into this back section, and then the stock actually comes out through these little openings here. And remember that the sleeve is all the way around there, so the stock is coming into this center area. These guys are going to spin, and they're going to push the stock out through the holes, and the rejects are going to be stuck in the middle here. Now what I'm going to do is I'm going to take this gasket off just because it's falling right now, and I'm going to go and start this centrifugal screen up because I want you to see these blades do not move. They're just stationary, and they're in there as a distributor. In fact, if we wanted to, we could loosen off these screws in here. This front plate clamps it, and you can actually change the angle on them so that you can get more coming in. So I'm going to go start it up right now. I'm going to throw the disconnect on. And when I start this up, we're going to keep our fingers away from here because it could hurt. And now I'm going to turn it on. Now you can see that the blades are staying stationary, the distributor blades, but the actual blades on the arms themselves to sweep the stock around are moving. Turn that back off. And so now you've got a fair idea of how that works. The distributor pushes the stock into this center area in here. So the stock is all fed and comes into this middle area. We're going to put flushing water, and we're going to control the temperature of that around 50 degrees C. So there'll be some warm water mixing with some cold water to actually make water at about 50. This is actually really as hot a water as we can get, and then we control it down to 40 degrees C. So the flush water is going to go in there. The chunks that get stuck in behind the screen, that is what won't pass through the screen, are going to go out as rejects, and we'll see them down below. And then the accepts, that is the good fiber, without the big chunks, is going to come down into the screen tank. It's a pretty basic and simple process. Okay. Okay. All right, the next thing we need to do is we need to take a sample of the wash stock, and we normally do about 3 samples of this to figure out what is the consistency, and then we're also going to dry it out, not only figuring out the consistency, but we're going to try and figure out how much rejects are actually sitting in here. And so I'm going to reach down into the tank and take a sample. I've got a representative sample. And there are some, you can actually see, if I turn this around, you can actually see one of those little chunks that I'm talking about in there is floating around. And the screen is going to take those out. Okay. Okay, so we're going to take some consistency tests. And Charles, if you can just get a picture of those 3 beakers that are sitting over there. They're approximately 1,000 milliliters each. And what we're going to do, and this is standard procedure, we're going to take and we're going to measure the weight of this filter paper on a scale. Then we're going to measure the weight of the slurry. Then we're going to measure the weight of the beaker. And once we've got all of that, we'll put it into this Bruckner funnel, pour the slurry in, pull vacuum on it, and take the water out. Then we'll take a pad, put it into an oven, and dry it out. Okay, so I'm here with the filter paper. Somebody has already written some weights on here, but they got them wrong. the scale, I'm going to tear that out. Okay, so it's going back to 0, so that scale is 0 now. It's measuring it at 2.5859, 2.60, call it 2.60. So this is 2.60 equals the filter. And I'll put that, and you make darn sure when you do this that you put this with the writing on the downside in there. Anyway, we're going to take a sample, one of these samples. I'm going to dry the weight off of this thing. And the slurry plus the beaker on this first sample came in at 1,183.8. I'm not going to worry about that extra decimal on there. And so now I'm going to take this sample. This was beaker plus slurry equals, what did I just say? I wrote it down, 1,183.8. grams. So now what I'm going to do is I'm going to take this filter paper. Come over here, Charles, and you can get a view of this. Filter paper is going to go in there somewhat close to center. And then I'm going to take the slurry, and I'm going to pour that in here. And when I turn on the vacuum, you can see it sucking the water out of there. I'm going to actually get some fresh water in here and rinse around in there. It doesn't matter how much water I add because we're going to suck it all out. So it's not really part of the calculation. This is actually looking pretty good. Just trying to wash it off the edges so nothing gets stuck. Charles, if you can take a shot of that, they can see how that water, you can see it being sucked right out of there. Okay, it's pretty well done. My fingernail and peel back filter. Ooh. Looks like it leaked around the edge. Shouldn't have happened. We're going to do 3 of these anyway, so it'll average. But what happened was that the fiber got in underneath there. And this is a hot plate. I got something that I was supposed to write on the back of that was number 1. I'll write it on the other 2 that they're number 2 and number 3. So we're going to do it again. This is number 2. Filter is going to be equal to, tear that out. 2.49. Slurry. Oop. Say again. Slurry is 1,060. 167.6. 1,167.6 grams. And that's the slurry plus beaker. What did I do with that other beaker? Slurry. Okay, one thing I needed to do was to take this other beaker, weigh it, just the beaker. So the beaker was 309.9. Now, this is beaker plus slurry. Pulling as fast, this one. I probably should have drained some of that water out, which I will in a few minutes. This guy's taking a little bit longer. The reason I'm holding it down is to make sure it gets good vacuum, because it can leak around these seals here. So this is our second sample. And you can see that it came off a little bit better. There's very, very little left in here. I didn't flush it this time because it washed underneath the filter. These filter papers are just a little bit large for this. You got to make sure you center them up as much as possible. Anyway, this is number 2, and I think I have a number written on the back side. It's number 2, the filter paper, the filter plus the slurry, and I will get the weight of that beaker in a moment. So that's going to go in there as sample number 2. And this is going to be sample number 3. And this is my beaker. Make sure he's good and dry. Tear out the scale. And number 2 beaker weighed 301. Okay, so the next thing we need to do is that we need to figure out what the weight of the shies are in here. And so what we're going to do is we're going to take 3 more samples. This time we're going down to a flat screen, We're going to vibrate the flat screen, read sample, and collect what chunks are left behind, what shives are left behind. The flat screen will actually suck all of the fiber through and get rid of it, and it will leave us with the rejects. And so then we'll put those on trays, what rejects we collect, and we'll put them in an oven and we'll dry them to see how many grams of bone dry shives there were. So we won't get that information until tomorrow. And then we're going to go through this same process with the screen stock. And we will see how much fiber was in there, figure out consistency, so we figure out how much fiber we got, and then also we will see how many rejects are left in that, and it should be significantly less. Okay, I'm going to take the sample now, and I'm going to do 3 of these. Okay, so we're going to go to the flat screen with our 3 samples. You can see if you look in here, there's little slices. This is called a number 10 flat screen. And then the flat screen itself, you look underneath, there's going to be a little offset cam in here which is going to vibrate. I'm going to turn it on right now. And all that's doing is that it's pulling on here. It's a diaphragm. It's going to try and suck it down. Okay? And so you can see what's happening here with the little air bubbles and stuff. I'm going to take this 1,000 liters of stock, and now you can hear it sucking it. What it's supposed to do is to suck all the fiber through, so you got to have this diluted down pretty good. And this will take it a while to do that. I can see the consistency is going down in here, so it's actually pulling fiber out, and the water is going out there. Okay, so I went upstairs and I picked up 3 trays like this, and I measured them, and they don't weigh very much. This one's 1.0233 grams. What I'm going to do now is you'll see that the fiber is all gone out of here, and all that's left are those tiny little bits right there. So I'm going to turn this one off, and I'm going to collect those guys and put them in that tray. I think that's, I still got a little bit there. Okay, so it's not very darn much. And now what we got to do is we got to go and put this in an oven and dry it out to find out the amount of dried fiber in that 1,000 liter sample. Okay, and I've got 2 more to do, so we'll get the average of it. Okay. Okay. So what we're going to do here, we've got these little trays, and we've collected the debris that came off of the number 10 flat screen from a given sample, and now we're going to measure it wet. And so I'm going to put it on this scale. It's fairly sensitive. It's so sensitive that you really need to close that door so there's no air drafts or anything going across. And that is now showing 1.0295. 1.21. Yeah, 1.21000. And you can see how it's bouncing around because it's we're measuring fractions of a gram. And in fact, the tray itself weighed 1.0233. So we're only looking at 0.1 grams for the weight of that fiber that's on there. So now what we're going to do is we're going to shut this guy off. And we will take this over and you can each grab one of those. Over to the oven. Put them in. And we will let them dry out for a day, 24 hours. Come back and get them. All right, we're just about ready to start up the centrifugal screen. And the graphic of that thing looks like that. And I described already what's going on in here. So now the first thing we need to do is to get this water temperature working, getting the flushing water working through here. And right now, we've simply opened the drain at the bottom of that tank, and we'll get that all set up and get it running before we begin to bring any stock over here. So the controls for that are the same controls that we use for the washers. So I'm going to go into washer controls. And as we mentioned before, this is running total warm water flow and cold water part flow. So this is actually a part to total ratio control. The temperature controller actually set points the ratio, FFIC 89, which is really just a multiplier. So if I start up, and I'm going to start up on manual, I'm going to manually open up the valve to 50%. So this valve is going to go to 50. And when it does, you might hear in the background water dribbling down through the tank. You can see the flow going up. I've got a set point of about 14 liters a minute set on there for lots of flushing flow. I'm going to put this controller onto automatic now. So I've selected it. It just goes to automatic. And now it's going to open up this control valve more and more and more, and eventually get up to that 14 liters a minute. Now, we're putting in hot water. So if you look over here, you can see the temperature starting to climb. It's 50 degrees, going to go 51, 52, and I want to get it down to 50. So to that, I'm going to add some cold water. So I'm going to go to this controller, which is the cold water flow control. And I'm going to set that guy's output to 50%. They're very small valves. And I'm now starting to get some water coming in. The ratio, I've got it set manually for 0.25. So it's going to take the flow, the total flow of 13.3, multiply it by 0.25, or 1/4, and that will actually make an output of 3.3 liters a minute, which becomes the set point to this guy over here. So I'm now going to take this cold water flow and put it into automatic, and it's going to open up its valve and bring itself up to set point, and hopefully that's going to start pulling this temperature down. You can see the temperature is now up at 55.7, and as we begin to add more cold water to it, then what should happen is that temperature should drop down. And we're running at our, well, it's 13.59 liters, but it's going to work its way up to 14. Temperature is on its way down now. Once we get close to 50 degrees, then I'll put this ratio control or temperature controller on automatic control, and it will adjust the ratio up and down, which will add more cold if in fact the temperature is high, or less cold if the temperature is too low, below the set point value. Okay, so the next thing to do is to go to the screen overview, and you'll see now that I've got 51.4 degrees C, water at 14.5 liters a minute going in, and my little animation here shows that there is water going into the center of the screen. So our next step after this is we're actually going to start the pump up, run stock through the screen. We've got to get the screen rotating. And I, earlier in this video, I actually turned that on so you were able to see it. And then once we get some stock coming through there, we'll make sure the drain is closed below, and then we go through the screen. Okay. Okay, so we're over at the center screen, and this is the warm water that's coming in on this hose. And you can see the jet, there's actually 2 jets deep in there. There's 1 jet, another one behind it, and there's 4 in the front. So there's 8 jets of water going in. It'll flush the rejects down this line, and of course the rest of the water is going right through the screen, so it's going down into the bottom of the screen stock tank, which right now we're draining to sewer because we don't want to fill that tank up with water. Okay. Okay, so what we've done now is we've got the agitator, the number 2 stock tank, agitating the washed stock, and then we're going to pump it from here over to the centrifugal. So let's go around here. So through a whole rigmarole of piping in here, eventually the stock is coming around to this line, see my arrow on the line, and through and goes into the back of the screen. In the back of the screen there's a distributor, so it's going to take the stock and spin it into the center of the stock. So are you closed down there? Okay, I'm going to start up number 1 stock pump. I'm going to start it now. And start the center screen. The stock is going down through there. You can see the rejects are coming out on here, and so the stock's being brought into the center section. The good stock, you can see it going through the holes, drops down, rejects are ending up coming out on this line here. And there's our green stock starting to accumulate in that tank. The number 2 stock tank is going to go down, number 3 stock tank is going to come out. Okay. Now you can see how the stock is kind of building up in here. The stock is going through that screen, and because of the impeller in there, you can also see, I can see little bits of sides, and I can see the sides going down there. You can see sides These are some of the rejects. These are really big ones. But in general, you can see the little chunks of wood floating in there. Now some of our good fiber went through there as well. You probably could get away with a little bit larger screen. But you can certainly see there's a lot of rejects sitting inside there. Okay, we said a few moments ago we were going to take the cover off. And so what we're going to do is that we need to lock out that screen. So gotta go around the other side. Can't see what I'm doing. Forgot to put my tag on there, but normally I would do that. Now we're going to go over to the screen. We undo all the bolts that are holding it in place like that. Remember, that's how it was. We took the rejects line out. So now the screen cover is going to come off. The screen itself right there. You see we still got a little bit of rejects stuck in here. So the stock was coming in. If you look at the back here, those veins that are sitting in there is the distributor. So the pulp stock comes down, goes into that chamber behind, and then comes out on each one of these veins. And then this is the actual blade that is spinning when the motor is driving. Okay, so we've got the centrifugal screen out right now, and we'll leave it out. We've got it locked out. But down in the tank now, you can see the wash or the screen stock. And I'm going to take a sample of that because we have to run some tests on that. And when I pull that, you look at it, and just from the look of it, there's hardly any rejects sitting in there, if anything. Okay, and we're going to get 3 of these. Okay, so we've gone through the centrifugal screen, and I've got 3 beakers over here, which this one is the rejects. You can see that there's a lot of shives in these guys. There's some big guys floating around in there, and there's some big ones in here as I bring it around. But there's also a lot of pulp fiber in there. And the screen isn't set up quite right. I appreciate that when we're dealing with something as small as we're dealing with here, compared to what's in industry, we don't have a lot of selection. If anything, the screen holes need to be a little bit larger so that the pulp fiber can get through because some of it was getting stuck with the rejects. And the flushing water on there was washing out fiber before it got a chance to get through those holes. So maybe the next run we'll actually take and lower the flushing rate down. I had it at 14 before we run it at 15. I may even try to go down to 10 the next time we run one of these things, just to slow the flushing rate down. The reason we're running a high flushing rate was that we were getting plugged up with shives inside the line, and we couldn't get the rejects out when we ran before. Anyway, moving on. Accepts look significantly better. I'm just going to mix it a little bit so you can see what it looks like, and I don't see any chunks in there. And I look at this guy, and again I don't see any chunks in there. And I look at this guy, and it's much the same. There's one little tiny one over there. So what we have to do now is we have to figure out what our rejects rate was, and our rejects rate is going to be higher than it should be because you can see here that we've taken out some fiber along with the actual rejects themselves. So we're going to do a consistency test on these 3 and then average it out, and then on the calculation we will figure out based on the amount of fiber that we had going into the washer, our screen, and the amount of fiber that was coming back out of the screen as to what our reject ratio was. And that'll be all this stuff. And as I say, it's going to appear a little bit high. Okay. Okay, so we have done the screening. We've actually ran a consistency test on these guys, and that's in the dryer right now, drying, so that we can figure out how much stock, how much fiber, how much bone dry fiber did we get after screening, and how much bone dry fiber did we have before screening. The rejects will be whatever the difference is between those two. Again, unfortunately, our screen isn't quite right in size, and so we're going to get a rather high reject rate because we rejected some pulp fiber as well. Now, if you look in this tank, he is now empty, because what I did was I took all the stock that was here and I pumped it back over to stock tank number 2, which is over here. So stock tank number 2, turn on the agitator. You should see a cloud of fiber coming up here, and now you don't see hardly any rejects floating around in there. Pretty clean stock. So the next thing we've got to do is start up a different stock pump and then pump this stuff to the cleaners. The first part is to actually get it running, and it's going to relieve pressure, what we call letdown control. It's noisy, it's just sucking air in there. And so there's a control valve which is sitting just back here behind me, and if I put my laser on it, and as far as you can get it, and that valve is taking the discharge of the pump and pumping it back to here so that we maintain a pressure of around 40-45 psi. And that'll be sufficient supply pressure to go into the cleaners, and then on the cleaners, all the way around here, the pump will be pumping up here, and there's the pressure transmitter that we measure the supply stock with. It comes along here, and there are 3 lines that we could open to the cleaners. I got a little X through here because this particular cleaner has never worked, whereas these 2 don't work too badly at all. So we will probably go on 1 and maybe go on 2. It won't take very long. The stock comes into the top here, just at the back, and I don't, Charles, know whether you can catch where they're coming in, but it's coming in here, here, and here. And it comes in on a tangent. So Charles, if you can get over here, maybe they can see the tangent right there. So it's not going into the center of this thing, it's actually coming into the side of it. That gets it spinning. And then what happens is that the heavies, the sand that is actually in the fiber, because we still got that. Remember that the tree was drawing nutrient out of the ground, and as it drew the water, it also drew up some sand with it, depending on the species, it could draw more or less. And what we're trying to do is get rid of that sand. So the sand will go down and it'll come out the bottom here as a reject. And later, once we get going, and this thing doesn't run for very long, it's quite quick. I'll put my hand under there, and you could actually feel the grit, okay, from the sand. The accepts come up the top. They'll go up onto this line here. So depending on whether we're running 2 or 1, I'll probably start with this one and then bring that one in. The stock comes back along through here and drops into here. We have to keep a back pressure on these things to work. So you've got supply pressure coming in at around 40, 42 psi. The back pressure, as I remember, we run that somewhere around 10 psi. So you get about a 30, 32 pound pressure drop. And we had looked at the whole idea of putting a valve on there to actually control that automated, but the process was over so fast that it didn't make sense. What we would do is we would measure differential pressure, and we would control the differential pressure to maintain a 30 psi differential across the actual cleaners themselves. So the cleaners will hydraulically function properly. If you don't have that differential across them, they don't work correct. The stock will then go back into this tank, and once it's in here, it has basically now been cooked, washed, screened, and cleaned. And the next place it would go in a mill is, well, it could be finished product. It could be going to a paper machine that is making corrugated paper, or making brown paper, or making materials for brown paper bags. It could be going to a bleach plant where we're going to bleach it, and we could bleach it with a 4 or 5 stage bleach plant, depending on how much brightness we want, how bright we want it to be. And if you remember from the PowerPoint at the very beginning, we're looking for removing all the lignins that we can out of there if we're going to use this for printing on. If we're not going to use it for printing on, then we would just use brown stock. Okay? So that's basically it. Okay, so back at the operating screen, I'm going to now pick on a cleaner overview. And this will give you a better idea of what's going on. I kind of changed the color of my stock in there from the brownie color that you saw before to a red, but I couldn't make it white in there because it's not. It is brown stock, but it's much lighter. At any rate, the pump number 2 that we're going to use will discharge its pressure and will maintain a constant differential pressure in there of control. We're going to maintain pressure, the supply pressure, at 300 kilopascals if we can. We have had issues with the pumps, and we may have to bring a second pump in there to help us a little bit. But we're going to try and maintain a 300 kilopascal, which is the 40 psi or 42 psi supply pressure. And to do that, we are doing that with this letdown control valve, the valve that I described. So once we got that pressure up, we then go into our cleaners. in a real mill, we actually had pressure transmitters on every single one of those things, special little diaphragm transmitters that would read back to us. So the operators could see how well the cleaners were functioning and tell when a cleaner plugged up or didn't plug up, because in fact, if the rejects plugs in here, you'll go right up to supply pressure. We're feeding our feed in, and I tried to show that tangentially coming in. The accepts are coming up this way, and again, back pressure on the accepts is going to run somewhere around 10 psi, which is going to be around 80 kPa, somewhere in that vicinity. And then we discharge down. We're going to use this little valve in here to throttle that. The rejects are collected in a rejects box, and when we were over there, we saw the shape of the cleaners, I think, and we saw the little box down at the bottom. And so then that also bleeds back out into the screen box, and we need to go and check and make sure that that line is okay. So we're going to try and start up stock pump number 2. We've been using number 1 for everything so far. Stock pump number 2 is right here. I want to look at the pressure control and make sure that I've got my valve partly open. Also, interesting enough, when we rebooted the computer, and this happens, all of the motor controls go to auto mode, and it really needs to be in manual mode so that we can operate it. So I'm going to switch that one to manual, and this one to manual, and this one to manual. We're only using this pump. So the pressure control, which is PB101, stock pump. These are the pumps. Let's go to cleaner control. And this is the feed pressure, 10.1, and it's set at 300. And I've got the valve at 36% open right now. So that's probably good. So we'll go to the pumps and hope that number 2 stock pump works for us. Noisy thing. Stop out. You see I got 98 kPa on there. Number 3 stock pump. I'm trying to remember which one is the noisier of the two. That's the better one. The US Very Drive is the one on number 2, and it's got a belt driven thing, and it makes a lot of noise. Pressure is only coming up to 38 kilopascals right there. So, and I wanted to get it up to 300. We've had issues with these, and may have to run both pumps. So I'm going to go back to screen control, and I'm going to put this guy down to about maybe 10% open. And the pressure is starting to climb, I think, or maybe not. Okay, we have to run both pumps, so we're running number 2 and number 3 stock pumps in parallel. The pressure has now come up to 305 kilopascals, and I was in manual, so I'm now going to go to auto mode. And what it should do is it should open that valve up a tiny bit, which I think is going up, and that will bring that pressure back down to 300 kPa. If we go over here, we've got a reasonably good flow. So this is the recirculation flow coming back in, and that's about what I want. Before we were running into problems with only one pump. The valve would throttle down so much the stock would get stuck behind it. So I'm quite pleased with this. Let's go back over here. So I said earlier that I wanted to get about 45 psi, and that's exactly what I got. The pointer's right on the black line. The next thing I'm going to do is to open up the supply into this first cleaner. You see the rejects going out through there. Actually, should be coming equally into the tank. I'm going to have to try and try. And you look in I can feel grit in there. And that's the rejects coming out. I'm now going to put a second one in. So a few moments ago we were showing you this guy was blasting really hard because we hadn't opened up the access valve yet, so everything was going down. This guy is now plugged. Okay. So there's no rejects coming out of there. Take them offline. But if you were to run your hand down through these, you can feel it's all gritty in there. Pretty hard to see it because it's very, very fine sand. Okay, so back to the operating screen. You can see that we're holding on dead on 300 kilopascals, which is what the set point was. Charles, go over to the screen. Set point is sitting at 300, and it's bouncing around 296. The valve is about almost a third open, well, just over 25% open, which is good. And what I wanted to see is up here my back pressure. My access back pressure is running around 66 kilopascals. So for posterity's sake, these are good values. This thing is running very well. For the cleaners, so there's no calculations. It was just a matter of demonstration. And we actually, those of us who were here, went and felt underneath the cleaner, and you could actually feel the grit, the sandy grit in your fingers from where the rejects are coming through. You can't really see it, but you can certainly feel it, because it is fine sand that has been drawn up through the capillary action in the tree as part of the nutrient. So back to the screen overview for just a moment. We went through and we have a whole bunch of calculations that we did. And Charles, if you can sort of get a bit of a video of that. Initially what we did was that in this area in here we did consistency on the wash stock before it went to the screen, and it was just nothing more than doing a conventional consistency check, and finally the consistency came out at 0.46, 0.409, and 0.498, which averaged out to an average consistency of 0.455. Now, the next thing that happened is that we ended up with rejects coming out of here. We're flushing with water and we were flushing out the rejects. We've had a lot of troubles over the years trying to get these rejects out of here. You could see it on the video that we went through in the reject part. But the problem that we've got is that it would always plug up on us. So we did a lot of extra cleaning up this year, just for this run. And we were running at 15 liters a minute in previous runs, and on this run I took it down to 14 liters a minute of flushing water to see what would happen. So when you look back at the calculations here, and Charles, if you can video back, come back in on that, this is now the sample we took out, and we see what the beaker and slurry weight were, and then we took and we used a 10-cut flat screen, which we took a video of, and all the stock that came through the rejects also was taken out of it, and what we got at the end was just the real true debris, the little chunks of wood, and we then have dried it, and we're going to go upstairs and take a look and see what the actual weights come out at for the dried fiber. And so the next step is to go upstairs and take a weight measurement. Okay, so we're upstairs in the lab, and I'm going to pull the samples out of here one at a time. Actually, I'll drag them all out. That was sample number 1. Sample number 2. And finally, sample number 3. And if you look at these samples, you'll see that there was a fair amount of debris in the first one. In the second one, there wasn't a lot, and in the third one, there wasn't a lot. That's why we're going to take a number of different samples. So I'm going to measure the weight of that one now. and it's coming out at 1.0469. And so I wrote that value here. That's my tray plus the debris weight. And the tray itself, I had already recorded the weight and put it on the, I don't know whether you can see underneath there, but on the underside of the tray I had written that weight in. So then we do the same thing with tray number 2 and tray number 3. I've already measured them out just a few moments before we started to take this video, so it didn't take so much time. But the weights actually worked out to be 1.049 for that one that seems to have the big chunk in it. And then these guys came down at 0.9953 and 0.905, not 1.0095. But the actual tray itself, okay, was quite, it's 1.02 for number 1, 0.9905 and 0.1085. So the actual debris came out at 0.0236 grams. That's what that debris in there weighed. And the debris on this one is 0.0048 and 0.0009. The percentage of debris then works out to 0.587 and 1.5356. These guys all get averaged up. And then what we do is we now look at what is the consistency that went into the screen and what is the consistency that came out of the screen. And so we can actually calculate how much fiber we got, because we did a consistency test, and it's not shown on here. We basically took an average of 3 samples. You've seen it when we did it over on this side. So now we've taken an average of 3 samples. It came out at 0.3394% consistency in the accepts tank. There's 423 US gallons in there. You multiply by the weight of water, which is 8.334 pounds per US gallon. And that came out to that weight there. Based on the consistency, 0.03394 times the weight of the, in that number, and that stock tank, the accept stock tank, came out to 11.965 pounds of fiber. Before we went into the screen, we had 13.63 pounds of fiber. So obviously we lost some fiber as well, and you could actually see it in the videos that you've seen, or where in fact there was a lot of fiber sitting in there. And the rejects rate actually calculates out at 12.431, and it probably should be a lot less than that. So in the previous tests, and I don't know how well we can get this, we ran a test last year in 2020 in January before COVID hit, and we came out at 13.668% reject rate, but we were running at 15 liters a minute. And that time I knew that we were getting a lot of fiber coming across, but we were always getting plugging happening with the rejects coming out. This time I ran at a lower flow rate, down at 14 liters per minute of flushing water, and the debris never plugged at all. Everything ran well. I think a lot of that had to do with the fact that we had washed all the lines well and got rid of the big chunks and anything that was in there. And so the next time we run this test, I'm probably going to take this down to 10 liters per minute. By decreasing the amount of flushing water in there, I probably, which is already proven because I went from 13.668 down to 12.431 reject rate by just reducing the water flow. So if I reduce the water flow down to 10, I may be able to get that reject rate down even lower, so that all we're really rejecting is the reject fiber rather than losing some of our good fiber. Okay, thank you.